Good afternoon, ladies and gentlemen. Welcome to today's Open Classroom webinar from a warm Cape Town. I trust everyone is safe and well. Today's webinar is officially webinar 62 in our Open Classroom series, which we began at the beginning of April last year. Please find video copies of the last 61 webinars on our website's webinar page, as well as around 300 short searchable FAQ videos which we have created from these webinars posted on the FAQ video page. Please also refer to our BIM webpage for more information with regards to Civil Designer's capabilities to contribute to any BIM workflow via the open format Building Smart IFC file type. What sets Civil Designer apart here is our ability to customize the data extents, i.e. a road's length, and the coordinate system of Civil Designer's IFC output design data files. Back to today's webinar, where we welcome back Andrew Cole, who many of you in the Western Cape will know well. During Andrew's presentation today, please feel free to use the text chat service on your GoToWebinar app or web page to ask us any questions you may have during his presentation. After today's webinar, we'll post a video copy in the webinar section on our website. So, good afternoon again, Andrew, and please take it away.
Hi there, and welcome to this month's Survey and Terrain webinar. In today's webinar, I'm going to be designing a dam wall using the traditional method of inserting the DTM points and then generating the dam wall banks with the terrace bank function. We'll then also have a look at the various area and volume calculations available in Civil Designer. So currently on my screen, I've got the natural ground surface displaying with the height shading. In the control center on the left here, we can see the height shading is displaying, and then I've also just got the quick contours at a 1 meter interval displaying on my screen. So we're looking at damming off this valley represented on the natural ground survey surface, and I'm going to then insert my DTM points. So just to start off, I'm going to move to the terrain surfaces, switch off the shading. So I'm going to display settings. I'm going to switch off the height shading and then just switch on that surface 1, which I've renamed to my NGL. Just switch on the surface shading. You can also just toggle my contours off. Okay, so the actual position of the dam I've drawn in a CAD layer. So I'm just going to go right click on the current layer window and make that layer visible to some circles that I've drawn in for the edge points of the top of the dam wall. Okay, so there they are. I've just zoomed into that predefined zoom view from the viewports, and then I'm going to use the model insert point, insert point function. You can also use the F5 shortcut key for inserting a point. Okay, and then I just have to do a J jump to those circle center points. So J jump, just have to make sure I'm setting the correct surface. So in this case, surface 2, I'm going to call those D, make it D1, and I'll allow that to increment. And then just the elevation is 1029.5. Okay, so that's my first point that I'm inserting on surface 2. Okay, and then the prompt once again just to identify the next insertion point. So I'm just going to do another J jump at the bottom of my screen there, and that automatically will increment to D2. The name's incrementing. So just J jumping to all my circle center points. D5 and D6. I Don't necessarily have to click on OK. I can just enter as well to close the dialog. Another J jump, enter, and then the final point, J jump, enter, and then just a right click, quit. Okay, and then I'd like to rename the surface for the dam wall. So just keeping the number, and then dam wall would be my surface 2 name. Just click away to make sure it's updated. And then just to display the point names, I'm going to use the ER filter, the name filter, only to display the points on surface 2. You can toggle the names and the heights on. So you can just verify what we inserted now, so that you can clearly see the elevation and the point names. Okay, could probably toggle the CAD circles off, so just right click on the layer and then switch the visibility of that CAD layer off. Remember, you can also switch off the CAD layer visibility from your control center. Okay, so I'm going to be adding lines, feature lines, to join up the points, and I'll just do a J jump once again. So it's model, feature lines, and I'm adding feature lines. So the feature lines are just a little bit stronger, more respected in the hierarchy. So I'm jumping to those points now. You can see it jumps to the actual point between the point name and the elevation. Actually on that decimal of the elevation. Okay, so I'm just drawing in the feature lines around the perimeter of the dam wall top. Right click and quit. Okay, I can switch off the elevations. Then I still need to draw in the triangulation lines inside the perimeter. So once again, just using the feature line function, just using spacebar to activate that. So just the diagonals, and then from one side across to the other side of the dam wall, just to complete the triangulation of the top of the dam wall. Okay, so there, that's all done. So that's just the initial positioning of the top of my dam wall. Okay, then I'd just like to change the color of that surface to something we can see a bit clearer on the shaded natural ground. And then I'm just toggling the names off. Okay, so I need to now do the banks, so terrace banks. So we're going to look at the fixed slopes and the variable slopes. But before I run that, I'll just have to work out what sort of search distance to use in the function. So I'm going to use the graphical join just to measure how far apart those furthest points are from each other. So it's about 96.4 meters. So can use a search distance of about 100 meters. Okay, so we're going to be generating our banks for our dam. So I'm going to use terrace banks and fixed slopes initially. So with the fixed slopes, you firstly would select your ground and terrace surface, and then the prompt would be to snap on your terrace point to identify that you're working on the correct terrace. So with fixed slopes, you can only have one value for cut and one value for fill. The section spacing is going to create triangulation lines every 5 meters, and there's my 100 meters search distance. We can just have a suffix added if we need to filter out those points at some stage. No constants or serial numbers needed. Okay, so that was 1 in 3 for cut and fill. In this case, generally everything is in full. But this left-hand side of my dam, the western side, we'd like to use a 1 in 2 slope. So to do that, we're going to use the terrace banks function again, but use the variable slopes. With the variable slopes, each segment could have a different slope specified. So just to identify which edge you're working with, we need to set a particular pen. So that is under the option settings, the file option settings, and under the terrain pens. And specifically, the full pen is the one that identifies which edge you're working on. So I'm just going to make that a bit brighter. And then once you've done that section, the perimeter pen fills in afterwards. So you can track with the perimeter pen what you've completed. So it's the terrain, terrace banks, and variable slopes that we're going to use to generate our dam wall banks in this case. You can delete if you want to remove banks, but once you run the slopes again, variable or fixed, it deletes the previous slopes that were created. Okay, so just the same ground and terrace surface, and just clicking on my terrace surface, using all the same settings. Okay, so you can see the yellow pen that I set. So it's identifying that segment that we're working on, and we're going to leave it at 1 in 3 slope for that section. The perimeter pen then comes in afterwards, and you can see the next segment that we're working on. So still happy with 1 in 3 for the inside portion of the dam. Around the bottom edge, we can leave that as 1 in 3, and then the front portion, the full slope, we're going to change to 1 in 2. The cut slope can stay the same. Okay, so just following that yellow line to see which segment you're working on. So that would be the last segment on the front of the dam, and then that side portion we're going to go back to 1 in 3 in full, and then just the last segment. So normally it goes around clockwise, identifying which segment to work with. Okay, no elevation or serial numbers needed in this case. And then you can see now the 1 in 2 full slope pulled back that toe point on the western side, the left-hand side of our dam wall. Okay, then just going to switch on the shading, and we can toggle off the points. I'm just going to do a 3D render view to have a look at the dam wall. So just a right click and then into the render view. Remember, you can drag with your control key in. If you drag with your left mouse button, you can tilt and rotate, and then just zooming in and out with the mouse wheel. You can see that 1 in 2 slope. I've exaggerated the vertical exaggeration slightly. It might appear a little bit steeper than it would at a 1 in 1 scale. But just to give you an idea of the actual shape of the dam wall. Okay, then just escaping out of my render view. Okay, to generate the dam volumes, we're going to have to merge the dam wall into the natural ground surface. Okay, so I'm just going to reset the filter, that name filter, so that everything is active. So reset, so the program can see all the names and points. And then just in my display settings, I'm just going to unshade these surfaces so we can see the triangulation lines on surface 1 and 2, and to see how the merging takes place. Okay, so we're going to run the terrace merge, so merging two surfaces. And it's the ground surface, our natural ground, the terrace is the dam wall. Merging that onto a new surface, separate surface 3, which we can rename afterwards. And then I'll validate that triangulation on the new surface. So Prompt is to snap on your terrace point, just to identify which one you're working with, and then yes to merge that particular terrace surface into your ground. The line model scans successfully just in that current view. So just zoom all and redraw just to view the new surface. Probably would be a good idea to validate that. Just going to rename that surface 3 now to merged NGL plus the dam wall. Okay, and then just click away. So just naming that in the control center. Alternatively, you could go into your display settings to the terrain surfaces tab and then rename it there. Just a double click should highlight and allow you to rename. Okay, we can always change the pen later on as well. Okay, so now I want to generate contours for our surface 3. So best to zoom all first and then terrain generate contours. So this would be for surface 3, the merged surface, at an interval of 1 meter. Okay, and that gets generated pretty quickly. Okay, now I'm going back to display settings and I'm going to set the contour display for those generated contours. So previously we would see the quick contours. In this case, we want to see the generated contours. Generated contours generally redraw a bit quicker than the quick contours, which are real-time dynamic contours. Setting a different pen, and then I can toggle the lines, triangulation lines off. There you can see those contours for our merged surface. You could also smooth them out. There is a smoothing option in the display settings. Okay, then I'm just going to have a look at the terrain 3D view. So that's the traditional terrain 3D view. If you have had a previous view, you could use those settings. Otherwise, you reprocess any changes. So that's the bracketed option is the no option. So I'm just doing the base surface, which is my new merged NGL with the dam wall. I suggest that you maximize it, just switching off that view axis. I can exaggerate the Z scale a little bit. And then we've generated contours, so I can switch on my generated contours and apply that. Okay, so you can rotate, tilt and rotate with the left, dragging with the left mouse button, and then you can move the whole site with the right mouse button. If you want to zoom in, you have to use the IZ view translation. If your cursor is in there, you can just use the mouse wheel as well. See the contours around the dam wall there. Okay, so we're going to be working out some dam volumes for this particular terrain surface. Okay, so now I'd like to do the dam volume calculation on our merged ground and dam wall surface. So I'm going to toggle the triangles on, the triangulation lines, and toggle the contour lines off so that we can see how the various depth bands during the calculation are generated. And we're going to be using the terrain pull down menu, the dam volume function. Okay, so dam volume. And then a couple of settings here, your water level you'd have to set. I'm setting that to 1027. Your ground surface you have to specify for the actual dam. And then the depth increments, you could make a little bit bigger, but I'm going to make it 0.1 specifically for the accuracy. And then a CAD output, you can have the water surface. So this creates a CAD polyline, 3D polyline. So we'd have the water surface or each depth increment. So from the 1027, 100 mils down, 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 creating essentially contours with those outputted CAD polylines. Okay, so I'm just going to do the water surface only for now. As a CAD output, you can also label the lowest point in the dam, and then you can create a reservoir output file that gives you those volumes at the different levels, the cumulative volumes that you could then use for your retention or detention pond storage for your stormwater design. Okay, so just maybe a little bit more information on the actual dam volume calculation. We're working out the volumes according to the actual depth increment contours. So it's a contour map of the dam essentially that we're working with all those depth increment intervals. So each contour we'd work out the area and then work out the volume based on the depth increment. And all those slices then get added up together. So the smaller the interval, the more accurate the volume would be, the final result. That's why I'm using that 100 mil slice or depth increment. Okay, so I'm going to run it. And then the prompt over here is to click inside the dam, inside my dam wall. And you can see from that 1027 level, those increments were generated. All right, so let's have a look at the output. So I'm just going to drag my output window open. You can see those 100 mil contour or depth bands, and the total over here, cumulative total, is 801,058 cubes. So this would be the output that you get for the reservoir file as well in the different depth increments. Okay, so that was the dam volumes, and another output from the actual dam volume function was this polyline that was generated at that 1027 level. So let's have a look in the properties. I've selected the polyline, and you can see the elevation over here, 1027. So that's our water level. So you could use that polyline to create a terrain string and then translate that to a DTM surface and then triangulate that to get an actual water surface. There are other ways to do it as well, which we can also have a look at. So for now, I'm just going to look at alternative volume calculation, which is a relatively new one. It's this terrain, the drainage, and the flood levels method. So the flood levels varies in that it doesn't have to be an indentation of the surface that we're working with. So the pond surface, in this case, we've got levels below 1027 on this side of the dam. So if I had to run the flood levels, it'll pick up the water on that side of the dam. So it's looking at the whole surface that you specify. So let's have a look at that. So flood levels, and I'm going to use that same surface, specifying my flood level of 1027, the same depth increments. There are a couple of CAD outputs here. So you've got polyline at the flood levels only, and then you've got polylines at every depth increment. You can also do solid fill, so hatching at flood level or at every depth increment. So in this case, I'm going to do polylines at every depth increment. And that would be output to this CAD layer. That's just the default flood levels CAD layer, but you can create additional layers. Okay, so I'm going to run that. Okay, the area has to be in view, so I'm just going to run it again, spacebar. Okay, and then we can have a look at those volumes. So in this case, 825,000. So the difference, that's why I kept these polylines on, is this volume of water on the other side of the dam. So if I had to run dam volumes, so we can just make a note of that, 825,026. If I had to run dam volumes, I'm just going to run the dam volume. With those same settings, we can do a CAD output. But this time, I'm going to run it on this side of the dam wall. So you can see there about 23,925. Okay, so if we had to subtract that from the 825, we also end up with 801 in the region of 801,101 cubic meters. So also quite a good check. The flood levels, so under drainage, and the flood level calculation. So as I mentioned, you can see with all those polylines that are showing on the screen, it's picked up the area over here as well. So it's worked out the volume of water on this side of the dam. So the flood levels volume calculation is very similar to the dam volumes, but the flood levels is a little bit more versatile, as it allows for separate ponding areas on one surface. Okay, so I'm just going to switch off those polylines, the flood level polyline CAD layer. Okay, so the next volume calculation method that I'm going to look at is the polygon volumes. So terrain, pull down menu, polygon volume, and you'll see there are a couple of options as far as how you determine the volumes. You've got a fence, perimeter fence, or you can define a polygon area. So you indicate the polygon graphically. So in our case, I want to use the fence method. We don't want to graphically go and click all around that perimeter for the polygon in this case. Okay, so that's what I first need to do. Define a fence. So that's under the model pull down menu. So fence, and we're defining a fence. So you can do that from a polyline, which we've got in this case, that water level polyline. Okay, so I can just click on the polyline, and that is our water surface. Okay, so we can use that now in our volume calculation. Just something, if you wanted to check the area, the plan area of the water surface, then we could have a look in the output window. So you can see down here when we defined our fence, it calculated the area, surface area, and the circumference of that fence. Alternatively, we've got the polyline still selected, so you could actually look in the properties bar and have a look at the perimeter length of that polyline, as well as the reported area over here, which is identical to what the output window is showing for the fence area and perimeter. Okay. All right, so back to our volume calculation. So we're going to go back to terrain and the polygon volume. So this time we have got a fence defined, so we can select the fence option as the area we want to calculate the volume for, and we're also specifying a level. So instead of a surface, like a terrace volume calculation, we're actually specifying the actual water level, no compaction or topsoil stripping, and then a couple of different methods to report your quantities. The band method, essentially horizontal bands, and the prism method is looking generally at columns and reporting um, the total in a depth column, and then you've got the contour bands that reports in actual contours. We could actually look at the help file. There's quite a nice illustration of the three different methods. Okay, let me just press F1 quickly. Okay, so this would be the band method. So basically a total for each depth band. Okay, so the different colors. And then with the prism method, the totals are essentially the red for cut and then red for full. So in those two depth bands, then the green for cut and full. So it'll only report those two that fall into that depth band. And then the same for that third band that's specified, the blue falls right through that whole band. And then the last band is the yellow area. So that would be the prism method. But the totals essentially would all be the same. And then the contour method actually reports it in the actual contour bands. So everything's separate, the cut and fill based on the contour bands. Okay. Alright, so in this one I'm just going to do the band method. Those depths, I'm just going to leave it at 1 meter. And then just OK. Okay, just to view that result. So 801218. So pretty close to our 801,000 that we got with the dam volumes on the flood volumes. You could probably make that depth increment a little bit smaller and come up with a slightly more accurate, but within that 801, close to 801,000, I think we're pretty close to what we're looking for. And then finally today, I just want to create a water surface, terrain surface, to have a look at the render view of the dam and the water surface. And then that could also be used for the terrace volume calculation as well. So just to create that surface, I'm going to have to create DTM points. I could use a terrain string, but in this case, I'm going to create terrain points straight from the polyline as we do when converting a CAD drawing with contour lines on it. So that would be using the model polyline to DTM method. And in this case, that polyline is already selected. I'm going to extract the levels from the polyline. It's a polyline with the elevation. I'm storing that to surface 4. We can make that feature lines. And a couple of options here for contours and for details. So you could set a spacing, how far apart you want the points other than all the vertices. But in this case, I'm just going to do the bend points. Where every vertex is on the polyline, we'll get a DTM point on surface 4. Okay. So those points were created. I can just switch that on quickly so we can see specific surface only. And if I put the names, or at least the heights on. Okay, those heights are a little bit small. I've set the elevations text size quite small, so you can see all those vertices have been turned into DTM points with that 1027 elevation. Okay, so I'm going to have to triangulate that and then create a surface so we can have a look at that in the 3D render view. Okay, I'm just going to rename this surface to water surface, terrain surface. Okay, and then I'm going to triangulate that with no length check, so it's the water surface. Okay, then I'm going to have to tidy up those triangulation lines where they're jumping across outside our surface. So I'm just going to switch off the visibility of that CAD polyline, the water surface CAD polyline. So you can see the perimeter has got feature lines that we defined earlier. So I'm going to use the model remove break lines, remove the crossing lines to remove those unnecessary lines around the edges on our water surface. So this is a relatively new function. You just have to cross over the lines. In this case, we're removing the break lines. So you can actually go over the feature lines. The feature lines are stronger. They won't be removed while we're removing break lines in this case. Quite a nice function to remove all those unnecessary break lines. Okay, so I've tidied up all around the edges and contained the break lines inside the perimeter of our water surface area. Then I'm just going to reset the filter, and then in the display settings just set everything to hidden, so hiding all the surfaces so that we can just switch that merged ground and dam wall surface and the water surface visible. And then I'm also switching on the shading for those two surfaces, and then just changing the color for the water surface. Just need to toggle those lines off, and then we're going to have a look in the render view so you can see the merged dam wall and ground surface and then our water surface. So you could do an additional terrace volume calculation now. Ideally with the terrace volume you should add some additional points in the middle of the water surface. But that's all I've got time for today. Until next time, take care, have a good day further, and cheers for now.
Thank you, Andrew. That was fantastic. And thank you very much to all of you who attended today's webinar. Please remember, if you would like any further information with regards to Civil Designer, or if you would like to request a future webinar topic, please use the email address listed on your screens right now. Once again, thank you very much for your time today. Have a great afternoon, weekend, and goodbye for now.